Hello and welcome back for another VMK in the game development series. This is the last VMK in the mini-series dealing with the font engine. In the last VMK, we implemented the monospacing font so that you can render text on the screen that's monospaced. However, you may have noticed that the font itself is really big and there's a lot of space between each letter that you have in the text. So to avoid this and to actually correct some other problems, we're going to go and modify the font engine so that it allows you to load in texture and then automatically space each character within this font engine according to the size of each letter. Then when you go and render things to the screen, everything is rendered properly so that the words kind of get crunched together and the spaces between words are large. I'll show you how all this works in this VMK. So let's get started. You remember last time we left off with displaying font testing at the bottom of the screen. Well, now what we're going to do is load in an extra font in the screen. Let's just take a quick look at what that looks like, and we see it there on the screen. I want to go modify our scene so that we don't have all this extra stuff being rendered, and we can focus mainly on the font. Let's see what we have here. Window, let's get rid of the window, and let's get rid of the houses. So we'll be left with just the ground and the font on the screen. Let's go make sure that looks okay. Okay, so there's our font at the bottom of the screen. Now, I'll label this font here Monospacing, just so that we can compare very easily with the proportional spacing font, which we're going to implement next. Now, notice that the P's and the G's are actually raised in the font, and that's because we didn't take into consideration that those are dangling letters. There are a couple other dangling characters inside this font, like the comma, the semicolon, the letter Y, and so on. So we need to modify our code so that we can move those letters down. As a matter of fact, let's do that first before we go and modify the proportional font stuff. Going into our font class, under build font OpenGL, in here we need to make some decisions. So what we do here is we generate a new list based on the list base number and the I value here. And what we're going to do is, if we're using monospaced fonts, then we check to see the I value. The I value represents which character we're about to compile. And we need to compare it with all the dangling fonts that we're going to be using. So for instance, if we're using the letter 44, 59, 95, 103, 106, 112, 113, or 121, those happen to be the ASCII codes for comma, semicolon, underscore, G, J, P, Q, and Y. And again, if we go back into our ASCII table here, we'll see the highlighted ones are the ones we're referring to. And here in the first column, we represent the decimal number of the character itself. So the comma is 44, the Q is 113, and so on. So that's where I got those numbers from in here. Now I'm subtracting 32 from it because you'll remember inside of our code for printing text, we offset by a factor of 32. So we need to do the same thing up here above. So if we go into here and we're using monospaced fonts and the current letter is one of these special ones, one of the special dangling ones, then we need to go and move our current position down by a factor. And the factor that I've chosen here is 16% of the size of the font. Now, if you choose a different kind of font, this number here may have to be modified by you, but for now I just hard-coded it in just to show you the general idea of how it works. So we move our font down, we go and render it here, and then once we're done, we need to go and move the pointer back up. And we can do that just by repeating the same process again. If our current value is one of those special ones, then we'll move it up 16%. You'll notice here we moved it down because there's a minus sign. Here we're moving it back up. Let's go save this and take a look to see what this change here does. You'll notice now that the P and the G are in line with all the other text, so everything has been shifted down properly. Now, with proportional fonts, when we're moving characters around, not only are we moving them up and down, but we also need to move them left and right slightly. The amount that we need to move is dependent on the size of every single character in the font. To facilitate this, I needed to create a structure that contains the data for every single font, for every single character in a font. Let's go back into our image here to take a look at what I'm talking about. With monospaced fonts, we had, let me bring up the grid here, we had all of our characters centered inside of its box. And again, the box here was size 50 by 50 pixels. Well, with proportional sized fonts, we're going to have the same thing with every single character inside of its box, but now all the letters and all the numbers, every single character as a matter of fact, is shifted to the left edge. And doing this basically justifies all the characters to the left side. Having the characters defined for me this way, I can then go through every single character and count how many pixels wide each of these characters are. Knowing all that data, I can then compile the following table. And I've placed the table inside the resource/fonts folder. I call it largeimpact_proportional.tga.txt. So the proportional font is saved here, and the data is stored in .txt. Now you'll see the way that this is structured is as follows. I have 10 rows of text, and I have 10 columns of characters. So inside this table, I actually have 10 rows of numbers, and then I have, for each row, there's 20 elements. The first two is the X and the Y coordinate of the first character. The next two is the second character, and so on. So for instance, if I were to look at this one here, this would represent the comma inside my image. I'm saying here that the comma is 9 pixels wide, and it needs to be shifted 8 pixels vertically. So if we go into here and I take a look at the comma, if I measure this, you'll notice that it's exactly 9 pixels wide. You can see that in the bottom right-hand corner. And I know just by the way that this font is defined that all dangling letters have to be shifted by 8 pixels. I started off with 8 as a matter of fact, but then I noticed once I ran a couple tests, I had to tweak these values just to get them aligned properly. So some of them are 6, some of them are 7, and so on. So all the ones that have zeros for the second parameter represent they're not going to be shifted in the Y direction. If there is a number in the second parameter here, then that means it does have to get shifted. So it's one of those special characters which we needed to modify in the monospace. The first parameter, the X value, tells you how wide each of these characters are. So it's a little bit tedious, but the general idea is this. You generate a font, you put it inside your texture, you position it so that the letter or the number or whatever is positioned right at the left-hand side of every boundary, and then you need to measure how wide each character is. Take all that data, save it inside a file that ends by txt, and everything before that has to be the same name as the image file that you're going to be using to save the texture. Then we can go back inside of our font class and write a little function here to load in all that data from that texture file. Having all that data, we can then go modify the current position using GL Translate so that we can position the text as we're compiling it inside this build font OpenGL. So now let's go and implement everything that I've just been talking about. Inside the build font OpenGL, we need to create a new local variable, and I'll call it UI gap. this is going to be how much space we need to give between each letter that we're going to be printing to the screen. Now remember, inside here we only define the size of the text, but not necessarily how much buffer zone has to be between each text. That's going to be represented by this UI gap. So if we're not using monospaced, in other words we're using proportional font, I define this gap value equal to be 5% of the size of the font. Then we can scroll down here. If we're using monospacing, we're going to offset the letter vertically. However, if we're using proportional font, then what we need to do is go take a look at this spacing array, and this array will contain all these numbers, and we offset in the vertical direction only. Then we go and compile the letter here, and then after it's compiled, we need to go and do the following. So now we move our current location to the right by the size of the letter plus the gap size, and then we return our position back up by however much the spacing in the vertical direction was. So here we move down by a vertical direction amount, and here we move back up by that same amount. But we need to make sure we offset everything horizontally by the size of the letter plus the size of the gap. In monospacing, we always offset horizontally by 50 pixels, which was the font size that was defined for us initially. Okay, now that we have that taken care of, let's go into our add font function and make some modifications in here. This is where we're going to make all the changes to load in that text file which contains all the spacing information. So I create a pointer to an integer, and this is going to contain our array that has all the values for the x and the y offsets. I then have a local variable here called setFilename, and the size of this file name is going to be the size of the file name that we loaded for the texture plus 5, because we need to add .txt to the end. If this is okay, we then go and create this setFilename by taking the file name of the image and adding .txt to the end. We then go and try to open up that file, and if it succeeds, I then allocate new memory to hold 200 integers. I need 200 because I'll have 100 x values and 100 y values, and each texture can hold up to 100 characters. I then create a couple variables here that we'll be using down below, and I set this Boolean array flag to be true. A counter initially is set to 0, and then I start off by going through all the rows and all the columns inside the text file. For every single value, I go and look for a number, comma, space, and another number with a comma at the end. Once I find this information, I go and save it inside the array which was initialized up here for the x value as well as for the y value. If the number of items read is not equal to 0, then that means there's something wrong with this text file. You'll notice that the structure of this text file is such that there's always a number with a comma and a space, and then there's a number, comma, and a space. Even the very last one. The very last one needs a comma at the end, or else this load function won't work. So you got to be sure that the structure of this text file is exactly the way that I'm showing to you. Okay, so if we didn't load exactly 2 items from the file, then BOK is set to false. I generate an error message saying that there's something wrong, and then we break out of this for loop. If everything is okay, I increment the counter by 2 and I continue reading. So this will go through every single item inside the text file. Down here, I guess I should scroll across here just to show you what the error message is that I'm displaying. It's just saying that the file format inside the specific file is invalid. Make sure that there's the appropriate number of rows and columns with spaces and commas between each of the numbers. Okay, so if there was an error, I go and clean up the memory that we allocated using the news for both the file name and the integers. And then we close the file pointer down here, and we also call safe delete for the file name since we don't need it here. Now notice it may be possible that we'll call safe delete twice for the file name, but that's okay because safe delete is written in such a way that it'll only delete it once, and then the second time if we call it again, nothing wrong will happen, so this is okay. Then we continue on down through here, but this time instead of passing in null for our last parameter, located right here, we can pass in our PI spacing. Now remember, we initialize PI spacing to null, so if we're using monospaced fonts, then this text file won't exist, which means that this constructor here will continue running exactly the same way it did before. If it does have that text file, then it's assuming that the texture is proportional, so it's going to load in all these numbers from the text file and then handle them appropriately inside the build texture OpenGL function. Or sorry, the build font OpenGL function. Let's save this and try to build it, see if everything's okay. Okay, so there's our monospaced font. Let's go and now add our proportional font. We can do this by going into initialize, and at the very bottom here, we'll need to call this a second time. This time we specify to load in our proportional font. That should do it, and then at the very bottom here, I want to go and display some text using the proportional font. So we'll specify here, we're going to use the ID number 2, which is the proportional font. I'm going to offset the font by, let's offset it by 100. And I'll make the font red so we can tell the difference between the two. And I'll change the text here. Actually, I'll leave the text to be monospacing, just so you can see the real difference between the monospacing font, which is the one in green, and the proportional font, which is the one in red. Notice I'm displaying the exact same thing on the screen, but the monospacing is crunched all together. The proportional font is crunched all together. The monospacing font is spread out really wide. So that's the main advantage of using proportional font as opposed to monospaced font. Now, when working with the font engine, either being it the monospaced one or the proportional one, there's a few key rules that you need to keep in mind. Number one, there are certain characters that you can't pass in here directly. For instance, let's say I wanted to print the number 2 divided by 3. If I go and do that, actually, before I render that, I wanted to make one other change here. I'm going to get rid of the ground just so it's easier to see the text on the screen. Okay, so if I run that, we see then number sign 2 divided by 3. Is that what I typed? Oh, sorry, my typing mistake there should have been the number 2 divided by 3. Okay, so that displayed fine. However, if I change this to this division sign and try to render the exact same piece of text, you see the following. The /3 turned into a G. Well, why is that? The slash here is a special character inside C++, so you can't display it directly inside quotation marks. If you want to use this slash, you need to represent it as a double slash. Now, when we go and run this, you see the slash actually shows up on the screen correctly. Some other characters that work similarly is the quotation. If I wanted to go in here and write I say hi like this, and we try to build this, then we get some error messages because this quotation mark is trying to get associated with this one, so the text that is getting displayed here is I say, and then the compiler doesn't know what to do with this part here. So to use quotations, we need to use this slash again, and this time the quotations will be handled properly. So there it is on the screen. If we want to use the percent sign, again, is slightly different. We can't just go ahead and say I got 100%, because if we do try that, let's see what happens. The 100%, there's no percent sign after the 100. To display a percent sign, we need to use the slash, and this time we use 2% signs. So we do slash percent percent, and then I'll type here today. So now you see that percent sign showing up on the screen. So those are the three main characters that you may try to use that have to be handled slightly differently. All the other ones you can just type away same way as you would normally. Everything that I've showed you so far has been static text. If we want to display dynamic text, we can do that as well. And let's actually modify our HUD function here to display the number of frames per second that our game is running in. We need to add a new line of text, so I'm just going to take this here and I'll paste it at the top. We'll use the proportional font, and I'm going to locate it close to the top here. And I'll change the font to be black. And for now, I'll just leave this here blank, like so. And I'm going to get rid of this stuff down here. So we should see nothing on the screen when I run this program. But what I want you to pay attention to is the current frames per second that the program is running at. Notice that in the title bar, it shows about 313 frames per second. Okay, now, if I want to render the frames per second down here, I need to get the frames per second value. And that value is actually stored inside of our game engine, inside game OpenGL. We have a function here, let's see, display frames per second in title. And the frames per second value is saved here inside this member variable. So what we're going to do is we're going to actually delete this function since we're not going to need it anymore. We're going to just take this and delete it. And that also means inside the .h file, we can go in here and delete it from here as well. Now, we need to get that frames per second value, MFPS, inside the HUD, so I'm going to pass it in as a variable. To do that, we need to go inside the scene.h, and we'll accept a parameter, a floating point parameter, frames per second. And in here, we'll pass it in. And we're going to display it on the screen. Just like that. This change here means that we need to go back inside game OpenGL.cpp, and inside our update game function, we need to pass in frames per second. Now there's one other thing we need to change inside game OpenGL.cpp, but I don't remember where it is, so I'm just going to try to compile this and it'll tell me where it is because it's generating an error message here. So inside frame, we deleted this function so we can actually go and delete that function call since it no longer exists. Okay, so let's go and run this now. And notice that the frames per second have jumped up from 313 all the way to 472, 75, somewhere around 470. So we got like over an extra 100 frames per second just by making that one change. And the real reason for this change is because inside that function we just deleted, we were calling new and delete every single frame. And that's pretty costly. So because we now avoid doing that, instead we're using the textured font engine to display our text to the screen. Everything can run much, much faster. Okay, the next thing I want to talk about is font size. Up till now, we've always been using a texture image here that's 512 by 512 in size. Well, what I've also done is I've gone in here and created two different textures for the Monospaced font. We have this one here, which is 512 by 512, and then we have this one here, which is the exact same font, but it's saved as 256 by 256. So now, instead of having a 50 by 50 pixel wide box that all the text sits inside, we have a box that's 25 by 25 pixels in size that each of the characters sit inside. I've saved this file as large_impact_mono2.tga. The original one is mono1.tga. Let's go and load this new font into our engine. Should be inside scene initialize. Right at the bottom here, we're going to just copy this code and paste it down here, and I'll just change this from a 1 to a 2. Now when we go and render text on the screen, I'll go and render text using both the large font and the small font. I'll change the frames per second to use this small font, which is number 3, and then 1 and 3 are the 1 is going to be the large font, 3 is going to be the small font. And I want to demonstrate the differences between the two, so I'm going to use the exact same text so that it's easier to compare. I'll change the color both to be black as well. Okay, so first we're going to render the small font up here, and then right below it we're going to render the large font down here. Both of them are scaling of 1, which means it's going to use the exact size that's saved inside the texture, and the font that we're going to be, and the text that we're going to be displaying is monospacing font. Save this and run it. And let's take a look at what we have. Okay, we noticed that the bottom line of text is correct, but the line right above that is actually all jumbled up and not looking very correct. Now the reason for this is because I made a mistake in the initialization section here. At the very bottom, our small font here doesn't use 50, it uses 25 spacing for each of the characters, so we need to change that. Now let's go and run it and see if the text looks okay. Okay, so now we see bottom line of text is large font, and the line right above that is the small font. It's all very pretty much crisp and easy to read. Now let's take a look at what happens when we start scaling our fonts. If I take that large font and scale it by a half, then it will be the same size that the small font is. And as a matter of fact, I'm going to move these two fonts closer together so it's much easier to compare. The font size is 25 pixels high, so I can put this at, let's say, 40. Okay, take a look at the line of text right at the very bottom of the screen. It's actually kind of sharp looking, like the edges are not very smooth, and there's kinds of extra pixels here and there that kind of make the text hard to read. The line of text right above it is the small font at its original size. It's actually very clean looking, and there isn't any sort of garbage on the screen. So this is what happens if you scale a large image down to be smaller. You get like sort of these sharp edges with extra pixels on the screen. We can also go the other way by taking that small font and increasing it by 2 times so that it's the same size as the large font. We'll need to separate the text a little bit more since the size of the text now will be 50 pixels. So let's make this 70, and let's take a look at what we get. Okay, now you see the bottom line of text is the original text, and the one right above it is the small text that has been scaled by 2 times. You'll notice that the smaller text, which has been scaled, is actually kind of blurry, and over top of certain letters there's a little bit of garbage showing up. It's blurry because we've actually stretched all the pixel data by 2 times. There isn't enough data to make it look smooth at a large font size, so all your curves end up kind of looking blurry. If you have your large text and you render it at its correct size, then you don't get that effect. Remember, it's very important that you know what size of text you want to use in your game. By knowing this information, you can then appropriately create your font texture to match the font that you're going to be using in your game. You can use the scaling for slight changes in size, but as soon as you start multiplying by like 2 or more, or by half or less, then the text itself is going to become difficult to read because it's either going to get blurry or it's going to get like sharp and jaggedy. The last thing I wanted to mention with fonts is that you're not restricted to having a plain colored font. I've only been showing you fonts that are one color, like red or green or blue or whatever. However, if you want to generate a font that has a lot of detail in it, so for instance, you maybe want to make it look like stonework, or maybe you want to make it look like straw, that's perfectly okay. Inside the texture that you use to generate your font, make sure you color everything the colors that you want to appear inside your game engine. Then, when you go and call this print text function, make sure you specify the font color here to be white. If you specify it to be white, then whatever color you see inside the texture is the color that will appear on the screen. If you want to change the color using this value here, you must make sure that your font inside the texture is white. So those are the kind of key rules you need to apply to. If it's white text, then you can use this here. If you want colored text, you need to specify this to be white, and then whatever value is in the texture, that's what it's going to be using. Okay, so that's about it for the font engine. I hope you enjoy adding text to your games.